In this video, we show you how we designed and built a robotic hand prop. The movement is controlled by wearing a wireless glove. We used CAD software to design the 3D printed parts. We began by printing bearing brackets and pressing ball bearings into the opening for the rotating shaft assembly. An end cap was printed for attaching the hand to the cuff, and threaded inserts were installed. Next, we printed the cuff and the shaft adapter. For the shaft, we cut a piece of aluminum tubing and drilled mounting holes at each end. We then installed the hand into the end cap. Now it was time to mount the end cap to the cuff. We printed upper and lower brackets for the arm, as well as the servo bracket. We also printed a hub to mount the shaft to the servo. Loctite was applied to each tiny bolt. Then the nuts were attached. Next, the shaft adapter hub was mounted to the servo. Here's a time-lapse of the assembly process. After assembling the arm, we tested the hand movement for the first time using our custom-built circuit board, which we programmed to turn the mechanism side to side. Now it was time to build the elbow and the upper arm. To do this, we replaced the upper and lower arm brackets with extended versions and added a mounting hole for the up-down actuator. We printed the remaining parts, including the elbow hinge, actuator mount, and large vertical brackets. Ultimately, the entire arm assembly will be attached to a tripod. Here's a time-lapse showing the assembly process for the upper arm and tripod brackets. The wireless glove controls the movement of the hand and arm by mimicking the motions of the wearer. The LEDs on the fingertips indicate the glove's current position. We custom-built the glove using the components shown here. The directional tilt sensor provides positional feedback to the wireless RF link, which broadcasts the data to the robotic hand. With the arm fully assembled, we were ready to test the capabilities of the glove. We temporarily wired the RF radio receiver on a circuit breadboard and used 3 different power supplies for the control circuit, motor driver, and RF link. After ironing out a couple of minor issues, we put the mechanism through its paces with real tasks. First, it poured water in a glass. Next, it served up some orange juice. Then, it tried to escape from its chains. The main goal is for the robotic hand to dispense Halloween candy, so we designed and printed a candy cup for it to hold. Here you can see the temporary supports being removed. We installed the cup on the hand and filled it with candy. After several attempts where we either missed the bag or dumped the candy prematurely, we finally achieved success. With the system fully tested and functioning properly, we converted the temporary circuitry to the final and completely self-contained finished product. As mentioned earlier, we used one of our custom circuit boards for the development phase. We designed this board using PCB software. At this point, we assembled a board specifically for this project and removed the wiring from the first board. We then mounted the circuitry to a bracket and installed it on the tripod. Here's a full view of the completed assembly. Before revealing the final scene, we demonstrate the full range of motion of the self-contained system. Thank you for watching. If you enjoyed this video, please hit the thumbs up button. Also, be sure to subscribe and hit the notification bell so you don't miss future content. More videos from our holiday series are available on our channel.